they're in the middle of just doing this 555 timer thing, and they've got to select a very specific capacitor. And the student in their write up, they have everything right. They've thought through everything. They were able to tell me what it was down to the microsecond, what timing this should produce. But when they told me what capacitor they used, they said they had used a 100 microfarad. the little weasels.
Yeah.
Little tiny
That's
weasels.
how capacitors work.
That's how they're just tiny weasels in there.
Yeah. So,
So hello. Hello.
anyways,
That's our little cold open. They're microfarad, for those of you who don't remember, FARDD. Do not call them ferrets.
they are not ferrets.
They are not tiny weasels.
Yeah.
That isn't how electronics works. All right. Let's go ahead and get started. We're introducing here your second quarter.
Yeah. Mechanical systems build, electrical systems build, and industrial programming.
So we're going to go a little bit into what the overview is of mechanical systems build, but we're also going to start out by talking a little bit about what generally you need for the three classes, and we'll just put that here, and we'll assume that you've seen it in the other classes.
Yeah.
So the main thing that you need to understand with these classes here is that this work that you're doing with the videos, it's all of the lecture portion of your class. So 3 hours of each week should be spent reviewing these videos and reviewing the slide decks that go along with these videos.
Yeah. And so just to kind of tighten that whole concept into one thing to remember, if we post a single 30-minute video for a week, we are going to expect essentially 3 hours of work from you based off of that 30-minute video. Yeah. And that's going to be taking notes and making sure you understand the content there. That's going to be reviewing the slide decks that we show. We are not going to go extensively slide by slide through every deck that we publish.
Unlike what you experienced in your first quarter, that's going to be a major difference here. We're going to be putting in front of you a lot more information, and that's information that you need to absorb at your own rate, and you need to formulate your own questions around to come and ask us when you're in class.
Yeah, absolutely. And doing that is and being consistent with that is going to be really important, because when we're in class this quarter, when we're in person, we are going to be solely focused on the application of the information that we communicated to you in lecture. And so that also means that we're going to anticipate that you come to class with questions. The information that we're going to communicate to you guys in this style of lecture format is going to be denser than what you experienced last quarter.
Yes. Because last quarter was just sort of a broad survey sort of thing.
Yeah.
Now we're really getting down into the particulars.
Yes, and we're diving, so like the electrical systems build, we are going to dive deeper into electricity and talk about aspects of electricity and electric systems that we did not even address at all in your first quarter.
When we talk about mechanical systems, we're going to get into calculations and do things around mechanical advantage that we did not do the first quarter.
And when we're talking about industrial programming, we are going to get into aspects about that were not part of the discussion. Like, you guys had an introduction to how digital signals work and how analog signals work in theory. Now we're going to start getting into the particulars about how we work with them in an automated system and with a PLC, and what a PLC actually does, and like how they work and how they talk to one another, and all of these other aspects of industrial programming and automation. That's what this quarter is about, building those fundamental skills.
Yeah. So, if you're not spending 3 hours a week, you're probably not doing enough work.
Approximately 3 hours a week.
Approximately 3 hours.
It might be more some weeks.
It might be more some weeks, and it might be more for you.
Yeah.
Like, the important thing is that you reach an understanding of these things, and then if you aren't able to achieve an understanding about it, like, it's okay. This is hard stuff. Come and talk to us. Come and ask questions in the class, because honestly, if we walk into a class and we ask, are there any questions on the videos? And we get nothing but blank stares. Our assumption is that nobody's watched the video.
And if that's the case,
Then
that
it's a different conversation.
it really is a different conversation. And the reason that it's so important for this particular quarter is because that there's going to be this very heavy emphasis when we're meeting in person, that we're going to be actually building systems and programming systems and working with physical hardware components. We are not going to have time, if nobody watches the videos, we are not going to spend 3 hours rehashing that
No.
week's lecture content.
No, we can't afford to.
Yeah.
So all we can afford to do is address the questions. So like there'll be probably half an hour's worth of addressing questions from the videos.
Yeah.
You know, but we can't afford to do anything more because there is too much work to get done. We have to build these systems by the end of the quarter and get them working.
And there's other practical skills along that pathway that we can really only address in person in lab. And those are going to be things about like how do you properly terminate like wires?
Yeah.
How do you align motor shafts? And how do you like set up bearings?
Well, I think we buried a bit of the lead here, actually.
Yeah, we probably have.
That this time you're going to be building systems rather than working with a system that's already built.
Yes.
So you're going to start with a whole bunch of components, and you're going to wind up with a system at the end of the quarter. So,
And that system is going, in the process of building that system, you are going to experience essentially the workflow that goes through every automation technician's mind when they're working with any system. And you're going to see troubleshooting, you're going to see documentation creation, you're going to see all kind like assembly, termination, wire management, all of those types of things come into play this quarter. And where we teach you those things is in person in the lab, which means that we anticipate and expect that you have consumed the lecture content ahead of time. Because if you haven't, we are not going to cover it in class.
yeah, we won't have the time. We have to deal what we're dealing with in person is solely the transfer from what we've learned, like the knowledge portion of it, and then translating that into an actual physical
Yeah.
skill.
We're turning it into application.
Yeah.
And this is also, quite frankly, the really valuable part of a program like this, because this is what you're going to be able to show people that you can do when you're done with the program, and this is what's going to get you hired.
Yeah. Yeah.
So
that's
I think that's kind of it. Do you want to broadly?
broadly we need to talk about what's in mechanical systems build as a subject. So mechanical systems build, we are going to be covering obviously mechanical systems themselves, the gears, belts, pulleys, levers, all of these things that go into that are mechanical advantage based or passive, like bearings and couplings.
Right.
And then we will also be doing some work on statics, which is the study of how forces work.
Mm-hmm.
So that's going to involve some trigonometry.
Yeah.
We'll be guiding you through that. It's okay that you haven't had trigonometry as a math. We'll walk you through that. It's just triangles, and it's not as bad as everybody makes it out to be.
Yeah. Everybody gets so worked up over sine, cosine, and tangent.
It's a simple chant.
Yeah.
And you'll be able to work that out. Your calculator does the hard part for you.
Yes, we advocate the use of calculators, eliminating human error.
Yeah, eliminate human error. Yeah. Exactly. So, it's going to be important that you come to us with questions
Yeah.
on that material, because that's going to be translated into things that actually matter when we get to work with physical systems.
Yes.
And the strengths of materials is another thing. Like, we're going to be drilling into things. We need to understand why we need to drill in them, what speed we need to drill into them. We're going to be doing all of these fabrication things.
Yeah.
We're also going to be mounting things, and we want to make sure that they don't droop, that they're stable,
That they don't vibrate off.
that they don't vibrate off, that they don't give us an earthquake effect, a poorly made tripod.
Yeah.
Oh, That was like a 4.5
Yeah,
on the
right.
Richter scale.
Yeah. The and then and then all of that is going to be knowledge, and then there's going to be the practical skill set that goes along with that, which again is going to be the things like, okay, we understand what types of bearings exist, but now how do we actually utilize them? How do we work with the physical component that is a bearing?
How do we get it on the shaft?
Yeah.
How do we get it to, like, do we need a housing for this? How do we make that happen?
And also potentially to the point is like recognizing like what are the features of a bearing that are important for the application that a bearing is being used for, right?
How do you know when a bearing's going out?
Yeah, like all of these types of things from the practical skill set side, this is the stuff that we get into in lab. And that's why, again, to reemphasize, we do not have time to cover the lecture material in person.
And then we also have,
Yeah.
like, just to make this stacked up, we also have within this class motors and drives. And
Which is a whole huge-
computerized control of all
Yeah.
of the aspects that we've got in this class. And so we've got motors,
VFDs,
like speed control, just push button control, all of these things that you can have for motors. We're going to be learning about in this class as well. So that means that you've got an awful lot on your plate
yeah,
as far as knowledge, and make sure that you're doing that.
yeah. So stay on top of the lecture material. Come to class ready to work.
Come to class with questions.
Come to class with questions.
Like, we see questions as a good thing.
Yeah.
If you have questions, that means that you're trying to learn it.
Yeah. The only dumb question is the question that you do not ask.
You
So-
wait to ask.
Or you wait to ask, right?
Yeah.
Don't suffer in silence.
If you start a job and you ask on the first day, how do I enter my time? That's not a dumb question. But if you work for a month and 2 paychecks have gone by where you've gotten $0, and then you ask the question, how do I enter my pay?
That is not the correct time to ask that question.
That is a dumb question
Yeah.
at that point.
Yeah.
It becomes a dumb question because you waited to ask it. So always ask a question when it occurs to you.
Yeah. And if it's on the lecture material, asking that question is involved in terms of documenting that question, writing it down, and coming to class ready to ask that question.
Yeah, writing it down is important. Otherwise, you're just not going to remember. I had something that I was confused by, but I didn't. Now I don't remember. Now that
Yeah.
I'm asking for it in front of class 2 days later.
One thing also, just as a note on taking notes and documentation. In mechatronics, you cannot remember everything. It just isn't, it is impossible. So, taking notes and creating the documentation for your machines to document what you are doing, how you did it, why you did it, all of that is very important, and it's part of the workflow that we're going to be practicing this quarter. We are
Yes.
going to emphasize this a lot. You will see it in all of the other classes that you take.
Yes, absolutely, absolutely.
I think, is there anything else that we need to hit on?
If we make mistakes in these videos
Yeah.
and refer to a day of the week or something like that, it's unlikely we will. But like if we do, please ignore that. We're speaking to you from the past. So whatever quarter we're recording this in is not the quarter that you're in. It's likely going to be a different day of the week or something like that.
So if we reference a Tuesday, or we see you in class tomorrow, but we don't actually meet the following day,
Yeah, don't pay any attention to that. We're going to try not to.
yeah, adhere to Canvas.
Adhere to what the schedule is in Canvas, what the schedule is on CTC Link. That's when you're meeting. Do not listen to us when we say, see you next Tuesday.
Yeah, we're gonna try not to do that, but if we slip up and we do that,
Yeah.
like ignore that.
Yeah. Absolutely. I think that's about all.
I think that's it. So we'll see you guys in the next video.
Cool. We'll see you then.